The pizzeria has 17 different toppings. How many ways could someone choose 3? Now, obviously, this is a combinatorics problem. You have to decide. The hardest part is deciding, is this a permutation or a combination? So real quick, let's go over that. A permutation is where the order matters. A combination is where the order doesn't really matter. So in other words, both of these you have one big group and you are taking out smaller groups. Now, does the order matter? Well, if I just tell people to group up into 3s, I don't care how they're grouped. So each group is the same no matter what order it's in. But if I tell you to group up into 3s and one of you is going to be president, vice president, and secretary, then the order matters because each little group can be rearranged into a totally different order. So, with this problem, there is no order. I just want to know how many different groups of toppings can I make. I don't care what order the toppings are in. They're all the same. So, this is going to be a combination problem. Now, you have to know your calculator as to how do you feed this in. Most calculators, the N and the R, the N stands for the total number of items. The R stands for how many items are in each group. And this is read, number of items taken R at a time. So if you're putting this into your calculator, now here's your formula. And don't forget that factorial. Like if I have 3 factorial, that means 3 times 2 times 1. It's multiplied this number times all the numbers under it. But most, even basic calculators have these 2 formulas built in. So, what we're going to do, we have 17 things. We want to take them 3 at the time. And this is a combination since I'm not concerned with the order of the toppings. When I put it into this calculator, I'm going to put my 17 in first. And then you engage the combination formula, taking 3 at the time. So that's going to give you a possible of 680 groups of toppings.